Thanks very much, Etna, and welcome to this panel on technology. My name is James Henderson. I'm Director of the Gas Programme at the Oxford Institute for Energy Studies. And with me today, I have three panelists, three excellent panelists, starting with Vanessa Miller, who is Director of Energy Innovation and Impact at Microsoft. Vanessa reports to Chief Environmental Officer at Microsoft, and her group's responsible for charting the way for Microsoft to be carbon negative by 2030. Vanessa also has experience in government. She started a career at the French Ministry of Finance and Energy, as well as having worked in the private equity finance of green infrastructure. I also have with me Yuri Sebrets, who's the Executive Vice President of Technology and Chief Technology Officer at Shell. He leads a global technology organization with more than 3,000 people in it, combining technical, scientific, and commercial expertise. He's responsible for Shell's technology strategy and new technology development, as well as external technology commercialization activities. Last but not least, I've got Patrick Child, who's Deputy Director General in DG Research and Innovation at the European Commission. He leads the policy for implementation, impact, and sustainable investment strategies. And as a member of the board of DG R&I, he follows in particular research and innovation in clean energy and climate technologies, as well as the research and innovation dimension of the post-COVID recovery and resilience strategy. So welcome to all three of you. It's a great pleasure to have you with me. On this panel, we're going to be discussing questions such as what technologies are needed to achieve a net zero world? Can we meet climate change needs using technology? How quickly can technology make a difference, and at what pace can they be developed and deployed? How are new technologies going to be financed? And perhaps more specifically, what technologies do each of the panelists think are going to be most relevant over the coming years and decades? And so I'd like to start by perhaps asking each of you for your vision, if you like, of technology and its role in the energy transition. And perhaps, Patrick, I can come to you first, and you can talk a little bit about the EU's vision for research and innovation.
Yeah, thanks very much, James. Very happy to be here. And I think that the European vision for clean energy transition is a really key dimension of the European Green Deal, this sort of headline policy for the European Commission, which we launched in 2019 under the leadership of Commission President Ursula von der Leyen. And this has been followed by a number of specific initiatives in key sectors. So things like renewables, including in particular offshore renewables, hydrogen strategy, renovation wave in buildings to ensure energy efficiency in buildings, as well as sector integration, making sure that all of the moving parts in the energy system fit together very smoothly, and a whole load of other stuff which I'm very happy to talk about. But given that energy accounts for 75% of our global emissions, it's obviously very important that as part of our European Green Deal and our green and digital post-COVID recovery strategy, that the energy transition and the research needs linked to that are at the center of it.
Great, thank you very much indeed. Yuri, let me come to you. What's the Shell view on technology as part of the transition, and how are you looking at that?
Yeah, thank you very much, James. I probably have to start with stating the obvious, and that we believe that climate change is the greatest global challenge of our time. And at Shell, we fully embrace the goals of the Paris Agreement against that background. And we want to be part of the solution that makes that Paris Agreement achievable. We're determined to rise to that challenge. That means, in part, that we already invest billions of dollars into technologies that exist today, in biofuels, in hydrogen, in electric vehicle charging, in offshore wind. And we invest in maturing new technologies that still need to be developed in order to get to a completely net zero energy system. It's driven by an overarching ambition that we have to become a completely net zero energy company by 2050 or sooner if possible. And that's then in lockstep with society and together with our customers, of course.
Great, thank you very much indeed. Vanessa, it's great to have a company like Microsoft, who's a sort of an energy consumer, but also obviously a contributor to the kind of technology-driven aspects of the energy transition. Perhaps you could tell us a little bit about your role at Microsoft and also how your company is viewing its role within the energy transition.
Thank you so much, James. It's such an honor to be part of this panel. So when we think about the role of technologies to meet this net zero goal, we're really thinking about two things. What are the technologies we can deploy today that are already kind of at scale? And what are the technologies that we can help enhance the business model via AI, machine learning, and digitization? And so really we're thinking of Microsoft as a customer zero. And that's kind of the role of my organization, is charting the way so that we can be on path to our carbon negative goal by 2030. But it's also using Microsoft as a platform to test the technologies that are going to be needed for the world to be on a net zero pathway by 2050, and really deploying these technologies within our four walls by being that customer zero. So when we pledge to be carbon negative, we really listen to science, and pretty much all of the scenarios from the IPCC are saying that we will need carbon negative emission solutions. And this is why we pledge to be carbon negative by 2030 and not just net zero. It's really kind of acknowledging that those that can do more should do more. And I think we'll talk a little bit about that. And then it's really thinking about the two pathway that we'll have to drive kind of on a parallel path. How do you reduce as much as you can? And how do you remove what cannot be reduced? And we really, for everything we do, we're really focusing on these two steps.
Okay, that's fantastic. Well, it's going to be really interesting, I think, to dig into that whole concept of you being customer zero. And I think what the interaction with customers and upstream suppliers is going to be. Let me now move on perhaps to talk about the technologies, or some of the technologies that we think are going to make a difference. Yuri, perhaps I can come back to you and let you sort of talk about some of the technologies that you see Shell implementing over the next years and decades to really help the world move towards net zero.
Yeah, thank you. That's quite a wide range of technologies. So my answer will not be comprehensive. I won't be able to touch upon all the technologies that we are involved in developing and deploying, often together with our partners. But let me start by saying, we look at the energy system as consisting of four segments that each need their own set of solutions. One segment is the generation of electricity, electrical power, and the distribution of it. The second is the transport of people and goods by road, rail, over water, and through the air. Third segment is industrial energy demand, both for making raw materials and finished goods. And then fourth is buildings, both residential and commercial. And the set of technologies that you deploy in each of these areas, partly overlaps, but in some cases also distinctly different. There's relatively easy solutions that already exist today. So personal mobility, is very clear that you can switch the world personal mobility system to e-mobility, basically, electric vehicles. All the technology exists today. It's mainly a question of building out the infrastructure to get there. But then on the other hand of the spectrum are really hard to decarbonize sectors. One of the most difficult is probably aviation, where all the technology solutions to get to scale still need huge amount of development. Could be bio-based energy, could be fully synthetic fuels, could be hydrogen. But that's going to take multiple decades, and that's also where you will need offset technologies such as carbon capture, potentially from the air, or at least from point sources, and nature-based solutions. And we're involved in all of this, and I could quote some examples if we have enough time. Then there's industrial kind of in the middle, maybe not quite as hard as aviation, but a lot harder than personal mobility. And in industrial decarbonization, the role of hydrogen is quickly emerging as absolutely critical. Hydrogen has received exponentially more attention in the last couple of years, and if we have time, I'd like to kind of go into hydrogen maybe a little bit later, deeper. But it's not the only solution. Another area where we put a lot of work on industrial decarbonization is electrification of the demand. To give you an example, the world's plastic supply largely starts with making monomers like ethylene. Ethylene is a major building block in the chemicals industry. Ethylene is made in crackers, which are huge consumers of energy. that energy is currently consumed in the form of gas that is burned in heaters. It's a well-established technology, but very big carbon emissions. If you could electrify that type of demand, that would be a major breakthrough. And we work together with a company like Dow in the Netherlands, where we pool resources and think about what would it take to come up with electrically driven furnaces that make a major building block that's central to the world's energy system like that. Very challenging, but also very exciting.
Thank you. Vanessa, let me come back to you, if I may, as a consumer. Are you thinking about the energy transition in the same way? Are you mainly thinking about electrification? Are you thinking about other forms of fuels? What's the Microsoft perspective on that?
Yeah, so I think when we look at the technology stack that we'll need to deploy to reduce our operational emissions, Scope 1 and Scope 2, it's mainly electricity decarbonization. But then when we look at our value chain emission, our Scope 3 emission, it's not one silver bullet, and it's going to be all of the above technology and strategy. And so all the technologies that Yuri mentioned are relevant. The question is, how big is our vested interest from an investor versus a technology provider? So it's really, every time we look at a technology, it's how are we invested in these two ways. If I think about the decarbonization of the grid, that can really help us decarbonize our Scope 1 and 2 pretty much to zero. First, we're one of the top corporate buyer of renewable energy. Our data centers and our facilities will operate with 100% renewable energy via long-term purchases that have really resulted in new built renewable energy facilities. That is a critical investment. It represents, gigawatt of investment by 2030. And second, it's how do we deploy digital technologies to enable tomorrow's grid and accelerate the broader decarbonization of the grid that really is the backbone of the data center and our facilities. We really think of our data centers as being part of the grid and as potentially a provider of services to the grid. And so we were one of the first data center to build grid interactive data centers, where we're providing ancillary services, frequency response, but also capacity to the grid, so that we can really implement this view of a multi-directional, or at least bi-directional grid, where the prosumer behind the meter is providing a service to the grid. And that's really something we're going to be looking at throughout, including for Scope 3. But for Scope 3, and we can maybe cover that a little bit deeper later, it's more challenging because of two reasons. First, data, and second, where also, of course, digital technologies can play a critical role. But second, because it's maybe more indirect, and so then it's really figuring out what's our role as an investor, as a purchaser, to really enable the decarbonization of our value chain, whether it's supply chain or downstream use.
Okay, that's great. Thank you. I mean, I will come back to that data point. I think it's a very, very important one later on, I think. Patrick, let me come to you and ask you to talk a little bit about the EU vision, particularly the balance, if I may, between electrification and other fuels, particularly gaseous fuels. Yuri's touched on hydrogen already, and we clearly know that hydrogen is becoming a major topic. Could you talk about how you see the balance of electrification and particularly the use of hydrogen in Europe?
Well, I think we're going to need both those things. I mean, the challenge that we have today is that many technologies, as Yuri says, exist, but many of them are still at a sort of prototype or demonstration scale. I mean, if we look at the speed and the pace of electrification that's going to be required, and the speed and the scale of the industrial transformation that we're going to need, we are going to need a massive upgrade in our capacity for electrification, and we're going to need new technologies to modernize and to improve our hard-to-abate sectors, as Yuri says. So, I don't think there's a trade-off between the two. We're going to need both things at a much greater pace and scale than anyone is at the moment, I think, in the general discussion, imagining. And that's where I think, working together between the industry, the research community, and the public sector is going to be really vital.
And in terms of the hydrogen strategy that as has been laid out, Obviously, we're at a very early stage. There's been talk about it ultimately displacing the gas market, I guess. How do you see that transition happening? It's a complex process.
Yeah, well, the European Union's hydrogen strategy was launched in the summer of last year with a really ambitious set of objectives. If you think that in the European Union today we have about 1 gigawatt capacity for hydrogen, what we're talking about is scaling up to 6 gigawatts by 2024 and then 50 gigawatts by 2030. So a really massive and rapid scaling up of the hydrogen market, and with a very strong emphasis, of course, on clean, green hydrogen. I mean, producing hydrogen from fossil fuels is not really going to solve our problem. So we really have to find ways of producing hydrogen using renewables at this sort of scale. And so our strategy, I think, has two main dimensions. Firstly, it's demonstrating and developing the large-scale electrolyzers that we're going to need. And then secondly, it's all about a concept we call hydrogen valleys. How do we use hydrogen in different interrelated aspects in the energy system, whether it's as an element of storage or a direct input in some of the large-scale industrial applications that Yuri was mentioning earlier on. So production of clean steel, for example.
Okay, thanks. That's interesting. Yuri, let me come to you then on the hydrogen topic. I mean, I think the debate around green versus blue hydrogen, if I can put it like that, renewable hydrogen versus steam reformed or methane reformed hydrogen is an interesting one. I think we probably all know where we want to get ultimately, but the road to get there is a bit more difficult. How does Shell see the development of the hydrogen economy?
Well, hydrogen, we see as an essential part of the overall mix of solutions. I don't think the world can achieve an overall net zero energy system without a significant amount of hydrogen in that mix. By 2050. And hydrogen, of course, is a type of technology where Shell is particularly able to make significant contributions. So we're going in, with quite a large amount of resource that we dedicate to that. We've got, if we start with green hydrogen, which is, the ultimate goal, we've got an electrolyzer up and running at 10 megawatts at our German energy park. We've announced investment in a 100 megawatt electrolyzer in the Hamburg area together with partners. We're aiming to build a 200 megawatt electrolyzer shortly after that at Rotterdam, fed by our offshore wind park that we're currently constructing. And then beyond that, we're looking to scale up to somewhere between 4 and 10 gigawatts electrolyzers in the north of the Netherlands, again, fed by offshore wind parks to be constructed. So very actively, being part of that scale-up journey and tackle the technical problems that it involves. There's the second important angle. You also have to start to create the demand for this hydrogen because you can invest in supply, but there has to be uses ready to take the hydrogen. And there's an element of chicken and egg there, where you really need to work together across the supply chain with your customers and also with policymakers to make all of that happen. So, for instance, we recently announced the start of a so-called Hydrogen Accelerate Consortium. That's together with Daimler Trucks, Iveco, OMV, and the Volvo Group, where we're working together with them to enable the mass rollout of hydrogen trucking in Europe. I mentioned some of the electrolyzer point sources that we are building. If those partners can make sure that the trucks are there to actually receive that, we could start a trucking corridor between Hamburg, the Ruhr industrial area, and the Rotterdam port area. And then you get a foothold and you can build it out from there for a larger network. But it really requires that collaboration to break the chicken and egg. There's another important element for this hydrogen system, and that's international shipping of it, because not everywhere in the world will we have enough energy density compared to the number of people that live there and the demand for hydrogen to make it locally. So we're working together in another consortium in Japan with Kawasaki Heavy Industries and several other parties to build a ship that can ship liquefied hydrogen. And it will be a demonstration that ships liquefied hydrogen from Australia to Japan. Japan is typically a country with high population density. It won't be able to produce all the hydrogen that it needs itself. This is quite a challenge. Liquid hydrogen is very, very cold. So all the technologies required to make that happen, require quite a lot of breakthrough. But we are very hopeful that this ship that is being built will see its maiden voyage towards the end of this year or early next year. The final comment I'd like to make is the dilemma between green hydrogen, which Patrick already mentioned, and blue hydrogen, which is making hydrogen from traditional technologies, starting with natural gas, but capturing the CO2 co-product and storing it away underground. Not the ideal end solution, but it is a production mechanism that can be scaled up much faster because it doesn't rely on the very large amount of renewable electricity that you will need to get the whole system to a net carbon neutral system. We therefore expect that the next couple of decades, scaling this up will be a mix of green hydrogen as well as blue, until there's enough renewable power in the world to have green only. But that's probably going to take a number of decades, and we don't have enough time to wait for all of that to come on stream if we are to achieve the Paris Agreement targets.
Great, thank you. The fact you're nodding, Patrick, I suspect means that you are in agreement with that sort of blue-green balance. Would that be right?
Well, today, most hydrogen that's being produced is brown hydrogen. So we don't do the carbon capture and storage piece of the equation. I agree with Yuri that the end objective should be fully green hydrogen, but we recognize that there will be an important dimension of blue hydrogen along the way, and that we do need to pursue all possible avenues in order to scale up the production of hydrogen as fast as we can. And I agree with Yuri that as well as creating demand, the key thing that we got to do is to produce hydrogen at a sufficient scale and at a commercially attractive cost, bringing down the cost of producing and distributing hydrogen to make it competitive with other fossil fuels. Is the key to what we need to achieve, and that's a key focus in our hydrogen strategy at European level.
Great, thanks. Vanessa, let me come back to you then and change the topic now. I think we've discussed hydrogen enough, and there's plenty of other technologies out there. Could you talk to us a little bit more about the topic you started to discuss in your previous answer around Microsoft's involvement in the electricity sector, the issues of demand side management perhaps, and allied to that, your use of perhaps big data to kind of oil the mechanisms, if you like, of the interaction between consumer and producer in the power sector?
Thanks. And really before I switch the topic completely to data for electricity system, I think there is a role for data and for AI optimization, including for hydrogen. We are working on tracking the hydrogen molecule, whether it's from a carbon emission standpoint or from just a tracking purposes of what would be the credits that would be allocated to the user, to an optimization of the pipes, of the integration of the hydrogen into the energy system at large, particularly within, as Yuri mentioned, kind of industrial complex or city complex. So there is a role for also enabling the deployment of these technologies more efficiently and potentially kind of contributing to enhancing the business cases of these technologies. And actually, where we are thinking about what technology fits in our goal, it's obviously related to the cost of carbon abatement. And today, hydrogen is too high of a cost, including maybe sustainable aviation fuels, to really have a central play in our goals within, whether it's scope 1, 2, and 3. But were that to change over time, that would obviously change how we stack kind of these technologies. And so we heard like this week or last week, the US government pledged this Earthshot to bring down the cost of hydrogen down by 80% to $1 a kilogram. That's like, if we see that happening by 2030, then how we envision the role and the contribution of hydrogen in reducing and meeting our scope 1, 2, and 3 is different than how we envision it today. So going back to data and electricity, this is for us kind of the biggest bet of this decade. electricity will need to double by 2050. We need to potentially quadruple the pace of renewable energy deployment in the next coming years. This decade is the decade of electricity. And really, this is where we think the role of data is going to be critical. So there's studies that are saying that AI can contribute potentially to 4% carbon reduction year over year. And we believe that the deployment of AI technology and machine learning technologies can really be an unlocker to the electricity system flexibility that would be required, as we see less and less fossil fuel providing that flexibility over time, and have more and more renewable energy being integrated on the grid, potentially up to 70% by 2050, according to the latest IEA report. We will need to manage the system in a much kind of real-time way. And it really becomes a multi-directional system. So we're obviously looking at how the system will integrate more batteries, how the system will integrate more demand response, and how we can work on optimizing power plants, both from an energy efficiency level, but also from a system integration level. And there is definitely a topic that's kind of also rising when we talk to utilities, is the resiliency of electricity systems as a whole. And we've seen that in the US recently in Texas, but also with cyber attacks. And as the grid becomes more digitized, what's the role there for enhancing this overall system? So this is for us a big bet, and where we believe that we can use our assets, our infrastructure, as a test case on a number of geographies. Not everywhere, obviously, but definitely in a number of countries in Europe and a number of states in the US.
I mean, what you're speaking to so it talks very much to the topic of partnership and cooperation across the value chain. I mean, are you seeing that operating very effectively at the moment, or is there much more work to be done there?
We have definitely embraced this energy transition with a focus on partnership. In fact, we announced last year a partnership with Shell, but also with other key energy majors. As you know, it's not even when we look at our sustainability commitments, it's not about ourselves. Like, we represent 16 million metric ton. It's big, but it compared to any energy major, it's 50 times to potentially much less bigger. So it's really about how we work together to find solution that can scale. In terms of where we've seen kind of movement, it really varies geography per geography. Europe, and I'm not saying this because this panel is with the European Union representative, but as being at the forefront, and including all the energy majors and all the utilities that we work with in Europe have been at the forefront. And some of our most like our flagship partnership have been with European partners. And it's sort of like, if you've seen over the last year, the European Union utilities have been the one that have taken net zero goals, embrace net zero goals kind of before other geographies started to embrace them.
Thank you. I mean, Yuri, that leads me back to you, I think, and to talk about Shell's interaction with customers. I think many energy companies are now focusing much more on their customers than they have in the past. Is that true in the development of technology as well as just managing the sort of the demand side of the energy equation?
Absolutely, it is both. I started off by mentioning Shell's vision of being a completely net zero energies company. And crucially, that includes our full so-called Scope 3 emissions. So the emissions from the use of our energy products at our customers' locations. And in fact, for Shell, that is well over 90% of the total. Our own operation is less than 10%. Most of the challenge is in helping our customers decarbonize, do this together. Vanessa mentioned one of many partnerships that we have, but a particularly important one with Microsoft, where Microsoft is helping us develop the AI and machine learning applications to drive that decarbonization. And in turn, we're also a very large supplier of renewable electricity to help Microsoft achieve its negative emissions target by the end of the decade. But that's one of many examples. I mentioned some other around technology development, for instance, on hydrogen earlier on. But you see this, in every area where we go after decarbonization plans in sectors. Maybe a good example is the shipping sector. International shipping in the world currently is still largely driven by burning heavy fuel oil in ships. Very, very carbon intense operation, but at the core of the international economy. Now, how do you get to something better? There's a range of technology solutions that you could go after. One is to potentially go for hydrogen as a driver for fuel cells, or maybe ammonia is an alternative, or maybe biofuels or natural gas. But of course, the whole chain of all the players in that system need to kind of synchronize their efforts, and they need to be synchronized with policy making as well to make that entire transition. So Shell is a founding partner of a partnership that is about getting the shipping industry to net zero. There's over 100 participants in there, from shipbuilders to ship owners and operators to large logistics freight forwarders to customers of heavy freight shipping, fuel suppliers like ourselves, and critically ports, because of course if you switch to another system, the port infrastructure needs to change as well, and it needs to change along international shipping routes. So we do technology development, but we do it in a partnership like that with many other companies. Another example is earlier stage technology development. As I mentioned earlier, I think we spend about $1 billion a year on research and development to come up with new and better energy solutions, partly in our own laboratories around the world, but a lot of that is together with partners, especially the earlier scientific work. So we work with all the world's really major iconic universities in various geographies to come up with solutions. We work with national labs. We work with startups that may have interesting solutions to offer. And for instance, in the latter space, something that's also relevant to the sector that Vanessa is in, we invested in a small startup called Esperitas. It's just one example. They've come up with a technology solution to immerse data servers into a cooling fluid and cool it in a fluid state rather than with blowing air through it. It's much more energy efficient and much easier to recapture the energy for other uses. Not only do we invest in a startup like that, we help them connect with potential customers, because it's typically a very small company initially that doesn't have all the contacts. And we've also developed the actual cooling fluids that will go into their design that will work, because our background in our lubricants business and our knowledge about formulating fluids that can do all kinds of different things is very, very helpful there. So again, collaboration with a range of partners in different ways, not only in transitioning the way demand is shaped up, but also to come up with new technology solutions.
Great, thank you very much. That's fascinating. Patrick, I want to come to you now and pick up a word that Vanessa used, which is resilience. How do you see the role? Are you concerned as we move towards a more renewable inspired electricity sector about resilience? How does the EU manage that, and how does the EU see its role in kind of fostering this cooperation between producer and consumer that we're going to need to A, develop technology, and B, to maintain the resilience of the system in what is traditionally a rather competitive energy market in Europe?
Yeah, well, I think it's a very important dimension, and I think that behind your question is the important recognition that it isn't only just about a race to develop new technologies and implement them as quickly as possible. That what we're talking about here is a transformation in our economic and social system and our ways of life. And one of the starting points for the discussion on the European Green Deal was a recognition that if we are going to make Europe the first carbon neutral continent by 2050, which is our objective, that we need to be thinking upstream about the socio-economic implications of what we're talking about. And that's a lot about the resilience of our societies, about not leaving anyone behind. And for this reason, one of the first things that the European Commission proposed when we set out on this agenda was something called the Just Transition Mechanism. So a specific financial support for the areas like the coal-producing sector in Poland and other places, which will help us to bring the whole of society together with us. Now, I realize it's a bit sort of a step back from your question about the resilience of the energy system per se, and which I think is absolutely important. And I agree completely with Vanessa's point that if we are increasingly trying to manage a power sector which is, approaching 100% dependent on a distributed production of intermittent renewables, this is going to be a real challenge to our traditional grid systems. And there, the digital agenda and all the things that she was saying are absolutely vital. Now, the European Union's role in all of this, is at different dimensions. Of course, we have a regulatory role, and we're at the moment preparing a package of legal proposals to support the what we call the Fit for 55. How are we going to get 55% reduction in emissions by 2030 as an important stepping stone towards full decarbonization by 2050? We can support research and innovation activities, and we can have a sort of convening power, bringing together leading actors, whether it's industrialists, whether it's the research community or public authorities, to think through the consequences of what we're doing. So, for example, we have an alliance on hydrogen, we have an alliance on batteries, and as part of our new industrial strategy, a number of other strategic value chains where we think that this sort of convening power of the European authorities can be very, very valuable.
Okay, thanks. Well, Vanessa, you inspired that question, and I'd like to come back to you now, if I may, to sort of ask you, as you look at the sort of technology development, what do you expect, or what do you hope for from governments to catalyze the incentives, if you like, to develop new technology? Are you looking for specific support? Are you looking for general policy direction? What are you expecting, and how hopeful are you now in the United States that things are going in the right direction?
Policies are really critical, and we are at this stage where we think we're really at this moment where policy can unlock so much with the ambition that we're seeing in both sides of the Atlantic, and that makes me, yes, indeed, very hopeful that we can meet even our goal of being carbon negative, which is a moonshot. This is how we called it when we started it. We need policies to really be designed to send the right market signal that will unlock new business model, that will help mobilize private capital. And we need this both in our economies, but also, I think you alluded to that, in emerging economies too. I mean, when we think about the just transition, it's both a very, very local issue, and it is for Microsoft too, as we think about the communities where we invest in, the communities where we invest our data centers, for example, where we locate our data centers, but it's also a global just transition. And so we will need this policy. When you talked about the collaboration earlier that needs to happen, well, it's at the industrial cluster and at the local level, but it also needs to happen at this global level. And that's I think where we kind of thinking we can have a role is both on this demand signal that we can help formulate to policymakers and to the suppliers, to the industry that would meet that demand. So that's a particular case obviously today with renewable energy. The tech industry is pretty vocal of the need of renewable energy and being powered with renewable energy, but we're also doing this on sustainable aviation fuels. We'll also likely, we'll do it on hydrogen or on other areas. Yeah, you mentioned, Yuri, shipping industry, even though it's not a big portion of our emission, it is some portion of our scope 3 emission. And so it is relevant for us to see kind of what are the corporate signals that we can send to the market that can really help shape these markets. And then the other piece is obviously the investment role that we can play, so that we can scale the businesses. And the last one is the role of technology to enhance those business cases. And sometimes it's not pure like digital technology. It could also be like just innovation on the business model. And kind of really the best scenario is kind of when we can try to tie the three together. And that's when we think we can be really the most successful. So we are really excited about that conversation that will be live over the next years and decade with policymakers, not only in the US and in Europe, but also globally.
Thanks. Patrick, you wanted to jump in, I think.
Yeah, I just wanted to react to what Vanessa has said, just to highlight the role of Mission Innovation, which is a community of countries that came together after the Paris Agreement, 25 or so countries representing the main actors in clean energy research and innovation, which had a really successful ministerial gathering to celebrate our 5 years of existence just earlier this month, and which set a new ambitious course. I mean, by coincidence, around 3 of the key themes that we've been talking today. So we've established missions both on hydrogen, on long distance shipping, and on the power sector and how to integrate renewables into the power sector. And I think this is a very powerful example of how we can, and I'm actually at the moment chair of the steering committee of this Mission Innovation community, and we're really proud to have been leading this discussion globally over the last years, particularly, welcome now, of course, the renewed attention of the Biden-Harris administration. And just one example of what Mission Innovation can produce in terms of cooperation between the public and private sectors. We had an announcement last week as part of this discussion on a new partnership between the European Commission on one side and Bill Gates and the Breakthrough Energy community of investors on the other side, aiming to mobilize $1 billion over the next 4 years in 4 key hard-to-abate sectors: hydrogen, sustainable aviation fuels, carbon capture and storage, and long-term energy storage with batteries. And I think that that sort of shows how when the public and the private sectors work together, we can start to achieve the sort of changes at the scale and pace that they need.
Great, thank you. Yuri, let me come to you. I think you wanted an intervention in any case, but let me also ask you, while you intervene, can you talk a bit about, from Shell's perspective, about the kind of outside the EU and the US dynamic, the kind of sharing technology with the rest of the world and affordability, as well as whatever intervention you were going to make?
Well, I think the topic of policy is so important that I wanted to add one more component to that. Fully support Patrick's views that governments can have a big role in stimulating innovation with some early funding. Fully support what Vanessa said, that demand signals are important. In fact, Shell has been a strong advocate in favor of carbon pricing internationally that helps the whole ecosystem to transition to net zero. There's a third type of smart policies that can also help. I'd like to get back to the aviation example. Back in January, Shell was involved in a world first. We announced that we had been able to make 500 liters of fully synthetic, fully carbon neutral aviation fuel in our laboratory in Amsterdam, using renewable electricity, hydrogen, captured CO2, and then all the chemistry involved in making kerosene out of that. And the Dutch national airline KLM fueled a flight with that and flew from Amsterdam to Madrid. Now, that is technically possible, but making fuel for aviation in that way is still so expensive that on a commercial basis, nobody will buy it. So it needs scaling up. Scaling it up will bring the cost down, but it's too expensive for governments to pay all of that. Yeah, that would not be affordable. However, what governments could do is put in place a small blending mandate. You could start with, say, mandating internationally that 0.5% or 1% of all the aviation fuel would have to be sustainable, from bio-based or fully synthetic. That gives a price signal to suppliers to start investing without it affecting the cost of flights much. So you get a just transition in terms of it still being affordable for the consumer. And as suppliers then build it up and demand holders start using it, cost comes down. You can stretch it to 5%, to 10%, to 20%. And in the long run, you can make the full transition on a market signal basis without having to have a very difficult, carbon tax, border adjustment, or other things that are just difficult politically to make happen. So I think smart policy will make an absolutely critical contribution to the world getting to where it needs to be. Your other question was on technology globally.
I'll just spot in. We've got about a couple of minutes left, so I'm afraid your comments will be quite short on this one.
Okay, well, you asked me the question.
I
try
did.
to keep it
To be
short.
fair, I did.
Clearly, Europe and North America currently, maybe from a technology perspective, are important players, but we're not the only ones. If you look at what the Chinese government is doing within their country to scale up renewable technologies, that's quite impressive. There's, of course, other parts of the world that simply can't afford to do that, but they will benefit from technology platforms that get developed elsewhere that ultimately will get deployed there. I would not see that as something that should be seen in terms of international competition as such, because the only way this global problem can be solved is through global cooperation and coordination. So I'd like to get it away from, this is a race between geographies. It really has to be a joint effort to get there.
Thank you very much for being so succinct. Vanessa, I'm going to give the last word to you. And again, with Microsoft being a global corporation, perhaps you could just talk a little bit for maybe 30 seconds to a minute on the kind of the more global nature of the transition and technology sharing.
Yeah, this is a critical question. And if we think about our scope 3 emissions, our supply chain is obviously mainly located in APAC. And so this is for us, we need to kind of embrace that transition in geographies where we may be operating directly less today, and need to kind of identify kind of the right ecosystem of partners to be able to deploy the solution that we will need for our suppliers, for our direct and indirect suppliers, for example. So there's different ways we're thinking about it. There's obviously how we enable and the deployment of these technologies by investing again in these technologies directly or indirectly, by being a corporate buyer of renewable energy in all of these markets, or by investing in equity or debt in solutions that in these markets. But APAC is going to be a critical test for a lot of the scope 3 for companies in identifying kind of the right partners locally to be able to deploy solutions at scale. And this is where we're indeed looking very actively at public-private partnership, including with multilateral development banks or with commercial banks that have kind of boots on the ground that can help us enable our suppliers to decarbonize and contribute to our goal ultimately.
Right. Well, thank you very much indeed. Unfortunately, we have run out of time. I have a list of questions as long as my arm, which we could have carried on with. But I'm going to have to say, Vanessa, Yuri, Patrick, thank you very much indeed for your fascinating contributions. It's been great to have the three of you here to give us a view across the entire value chain and policy perspective as well. With that, I'll bring this session to an end, and I'll hand back to you, Etna. Thank you very much indeed.
Thank you.